Good day, everyone. This is the first part of Lecture 1 for IE 298, Introduction to Life Cycle Analysis. We will start with an overview of life cycle and systems thinking. And to do that, let's start with considering some of the questions, in particular for an energy system, that can be tackled using life cycle analysis.
Okay, so these are the questions that you might be interested in considering which energy technology is best to invest in. So for example, which one will result in the lowest cost, which will be most financially feasible to investors, which is the cleanest technology, which will result in the lowest criteria air pollution, for example, or the lowest greenhouse gas emissions, and which will result in the least disruption to culture and societal value. Okay. Of course, I'm not claiming that LCA will help you answer all of these questions. No? Siguro ang pinaka-relevant ang LCA would be bullet number 3, okay, under the overarching question. But you can also use it, of course, for bullet number 1, because actually life cycle cost analysis, yun yung pinaka-parent framework ng LCA. Okay, so what is life cycle assessment, or what is life cycle analysis? LCA is a method for estimating and evaluating the environmental impacts of a product, okay, and a product meaning a good or a service or a system over its lifespan. And as you can see here, if we can blow this up, okay. Life cycle stages would include R&D. Okay, magsimula tayo sa R&D. So as mentionalization itself. Okay, R&D stage pa lang, you already have your inputs. Okay, syempre you have to test, you have to experiment. Okay, and you would have outputs in the form of the product itself as well as the waste. Okay, and then you have extraction. Okay, extraction of the materials from the Earth's surface that are needed in producing and actualizing the product. Okay, and again, you have inputs and outputs for this. And then you have processing of the extracted raw materials. Okay, processing into products that will later on be used for manufacturing and assembly. Okay. And then, of course, after manufacturing and assembly, it will be distributed for use by your consumers. And take note, between each life cycle stage, there's transportation activity going on. Okay. And then, of course, you have end of life. No? End of life from use, okay, after the product's lifespan. Okay. And of course, there's some transportation also involved. But in end of life, you can manage the waste in such a way that you may be able to reuse it. Okay, so from supposed disposal to reuse or remanufacture. So take apart the parts of the product so that you can use the different parts for manufacturing or assembling other products or the same product, or recycle. You extract the raw materials. Okay. From the supposedly disposed product. Okay, so these are the main life cycle stages. And that's why we say when we do LCA, we are doing an analysis from cradle to grave. Nagustuhan ko tong picture na to kasi merong kamay na parang lumalabas. Gusto niyang ma-resurrect. Yung gusto natin mangyari dun sa recycle, remanufacture, and reuse. No? Okay, so particular example, okay, sabi natin, extraction of raw materials. Familiar ito. So sa manufacturing plant, okay, you have your canned soda. And then it's being transported, distributed to different areas until you have it in your fridge, okay, for you to be able to drink it. And of course, you have to dispose of it. Or maybe i-recycle yung cans na yan, no? Okay, and of course, we want to do this because the impacts of a certain product or system goes beyond the use phase. Hindi lang naman nakakoncentrate dito sa pag-inom ng soda, okay, yung magiging environmental implications ng Coca-Cola na ito. As you can see, there are so many things that are happening upstream as well as downstream, okay? And these impacts can be, for example, can be in the form of fossil fuel depletion, of global warming, of ozone depletion, of acid rain, okay? And in estimating environmental impacts, okay, we use indicators, okay? So indicator for fossil fuel depletion could be fossil energy use, okay? And the unit of measurement could be BTU or MJ, okay, megajoules. And then for global warming, the indicator could be greenhouse gas emissions in kilogram CO2 equivalent, okay, for ozone depletion, etc. Okay, so in estimating, we want to quantify, and of course, we want to use a specific unit of measurement, okay, and the relevant indicator for that environmental impact. Okay, now LCA is a useful tool and framework for answering interesting questions such as, is it really more environmentally friendly to use paper grocery bag versus plastic bags? Or maybe using physical CDs, music CDs versus digital versions of the music? Okay, ano kaya ang mas mataas ang environmental impact? Or what are the scenarios in which one is better over the other? Or disposable versus cloth diapers? And of course, you can also ask, is it better to have coal power plants versus solar PV plants? Okay. And you can also ask, what has the biggest impact? So, na-mention kanina, we want to look for the hotspots. Which life cycle stages have the biggest impact, and why do we want to know which has the biggest impact? Because we know that we have limited resources in most cases, so we want to prioritize, okay, our efforts, and so we want to know which has the biggest impact. Nagsisimula ba siya sa paggawa ng semento? Meron isa dito na working with the cement industry, sa semento o sa pag-construct, for example, for a house, no? Sa pag-construct ng house itself, okay? Or dun sa how you live in the house itself. Okay? Ano kaya dyan sa tatlo simplified na stages ng isang house, okay? Isang bahay, ang may pinakamataas na environmental impact, okay? And saan dapat pagtuunan ng pansin in terms of steps to curb environmental implications. It can also help us actually in life choices, lifestyle choices. How do our dietary choice affect the environment? So, mga interesting questions. What is the significance of buying local? What is the significance or the environmental impact of being a vegetarian? If you do these things, how big of a difference can you make in terms of contributing to a more sound environment or towards sustainability? Okay, and of course, you might be thinking, if you estimate these environmental implications, who should be responsible? Who should be responsible? Sa simpleng burger, right? It has so many components, not just the ingredients of the food itself, but also the packaging, and all the other condiments that come with it. They also come with their own ingredients and their own packaging. And each of these parts have their own life cycle. Okay? Given this, sino yung responsable dapat? Okay? And this might not be a question that is directly answerable with the use of LCA, but at least you have an idea. Okay? You can get an idea where the biggest environmental impact comes from. Okay? And so you would know which stakeholder should be nudged in the whole supply chain. Okay, and it can also help you with a wide range of policy questions. So for example, what are the climate implications of electric vehicles? can they actually help mitigate climate change? Of course, ang popularized sa media is that they do. Okay, but are there instances or circumstances wherein they don't? And what should be done with respect to these circumstances? Should we phase out fossil-based power plants and embrace renewable and alternative fuels entirely? Will carbon capture and sequestration help, for example, in mitigating climate change? And then, should the Philippines pass a law on extended producer responsibility? So these are policy questions that can actually be helped. Answering these policy questions can be done with the use of life cycle analysis. Okay. Now, I'd like to go through some topics from previous semesters just so you can have a better idea of what I'm expecting from this class. I put this on the right side. Okay, so this is actually an article that was published in the International Journal of Life Cycle Assessment, and it was an output by one of the students in my class, LCA class, in 2018. No? Life cycle energy use and CO2 emissions of small-scale gold mining and refining processes in the Philippines. So she did this, Miss Senya, she did this as a topic for her project in my course, okay? And we co-authored it with Dr. Soriano and Ms. Gutera, who were actually part of a bigger project on life cycle analysis of life cycle sustainability analysis of small-scale gold mining in the Philippines. So Ms. Senya got her data from the project of from the LCA of gold mining project headed by Dr. Soriano. Okay, so you can also do that now if you have you want to use maybe part of the data of other research projects that you are involved in or you are familiar with, then we can definitely talk about that. Other topics included LCA of cooking options in the Philippines. So stovetop versus cooking stove versus electric and other options. And then you have greenhouse gas impact of chimney modernization. And then somebody also looked at LCA of eco charcoal. One looked at the LCA of Bangi wind turbines in Ilocos Norte. There was one study of residential solar PV installation in Metro Manila. So using LCA to inform households, okay, whether or not it's valuable to install solar PV in Metro Manila. Okay, that was also interesting. And then you have LCA of proposed solar PV installation in UP Manila Pharmaceutical Institute. And of course, solar PV versus energy efficiency in Baguio. So different locations. Okay, so pwedeng you also want to look at the same technology, but you would like to investigate it in a different application, a different location or context, right? Okay, so I already provided some, I guess, convincing situations why you would want to use LCA. Okay, but I'd like to emphasize, no, in those situations, intuition is actually not sufficient. So LCA helps you because there are complex questions wherein your intuition is not sufficient, a sufficient framework for analysis. Okay, and LCA will provide you a systematic method for comparing the products and policies over their life cycle. Okay, and of course, this is relevant when thinking about sustainable development. So I'd like to show you the definition of sustainable development from the Brundtland report, which is probably already very familiar to you, no? So i-remind ko lang, sustainable development is the kind of development where you meet the needs of the present without compromising the ability of future generations to meet their own needs. Okay? So merong equitable yung pag-develop across generations. And we emphasize this because the nature of humans is mas mahalaga yung now kesa sa future, of course. Diba? May pagka-selfish yung view natin in terms of spending resources. Okay? Okay, and LCA also provides basis for solutions that prevent shifting problems from one stage to another, as I mentioned earlier. And then it also helps you to prevent switching from one burden to another. You might be lowering, say for example, CO2 emissions, but in the process, you are increasing SO2 naman, no? So we don't want that. Okay, so suppose you are considering 3 technologies, technology A, technology B, technology C. And as you can see at the bottom, nakalagay sa ilalim ng figures yung stages. So simplified to, as you can see. So for example, ito, year 1 to year 5, pare-pareho sila design to manufacturing. Pero yung use phase nila, magkakaiba yung length. No? Yung length ng period of use. And then of course, you have your end of life. So for example, pag dismantle, so it takes time also to do that. Okay, so you have these 3 different technologies, no? Technology A, technology B, technology C. And say these are the impacts as shown by the bars. Okay. Madali bang sabihin kung alin yung pinakamagandang technology? What do you think? Isa sa mga important things that you have to take into consideration, no, which is the useful life. Okay, so hindi direct yung magiging comparison natin dito kasi one, hindi natin pwede sabihin na okay, technology A kaagad, although parang obvious na siya yung may pinaka-konti in terms of if you just add all the impacts all together, no? But as pointed out, mas maiksi yung lifespan niya. So if you want to have an apple-to-apple comparison, you would want to be more inclusive in terms of the lifespan of technology B and C, okay? And therefore, yung technology A, baka mag-repeat yung ibang life cycle stages niya. And what would that look like? Okay? What else? Meron bang ibang comments dito? Sige, let's move on to the succeeding slides. But that's one important thing to take into consideration, no? Okay. Kung titignan natin, okay, if we compare the results based on life cycle stages covered. So, say for example, dito, i-consider lang natin yung design and manufacturing stages. Ang magiging conclusion natin is what? Pinakamaganda si technology B, right? Okay, just to make it clear, no, na kapag di ka nag-life cycle study, okay, tapos nag-focus ka lang sa isang stage kasi yun yung pinaka-popular or yun yung pinaka-accessible to your mental framework because that's what you're familiar with, okay, then you might make the wrong conclusions. Okay, so for example here, alam natin na yung buong picture ganito pala, but if we did not think in a life cycle thinking way, then we might make the wrong conclusions. So for example, here, ang conclusion natin is technology B ang pinaka mababa ang kanyang impact. Okay? How about sa ibang life cycle stages, if we include them, okay? If we look at the use stage only, okay, syempre magiging conclusion natin technology A, right? Everyone can follow naman, no? Simple lang yung example natin. Okay. How about if we base it on, as I said earlier, design and manufacturing stages, it would be technology B. How about if it's end of life? Again, it's technology A. So, pwedeng mag-iba-iba yung conclusion mo depending on the life cycle stage that you are focusing on. So, another important point that we want to make here is that your system boundary later on will be very important in terms of the conclusions that you will be able to make at the end of your study. So you might have, for those who are familiar or for those who will look at literature reviews of LCA studies later on, you will notice now one of the things that they will be pointing out is that there are differences in system boundaries. So you cannot really directly compare different life cycle studies because of these differences in life cycle boundary. Okay? Syempre, kung iba-iba yung stages na kinonsider, magkakaiba din yung magiging conclusion. Okay. And as mentioned kanina, no, yung useful life, the useful life is very important. So if we say we consider a 60-year analysis period, okay, anong mangyayari? So this is going to be the cumulative impact, no? As we can see, mas mataas yung impact cumulative impact ni B all throughout or most of the life cycle, okay? And then there are periods wherein technology C has lower environmental impact than technology A. But then again, cumulative impact is not very useful, I guess. Or it can be useful in some instances, but it's not the best metric to look into. Why? Kasi dito, tinitignan lang natin total impact, but how about the usefulness of the technology? Gaano ba karami yung napoproduce niyang energy, for example, diba? So, the better way to compare actually different energy technologies or products for that matter, okay, is based on their functional unit, okay, which we will discuss later on, para magkaroon kayo ng apples to apples comparison. So again, why use LCA? Sometimes your intuition is not sufficient framework for analysis. Okay, it provides you a systematic method for comparing products and systems. Okay, and we want to always take into consideration this one, no? Sustainable development. And we don't want to shift problems from one stage to another or switch from one burden to another. Okay. So what is LCA? We move on to more formal definitions. Life cycle analysis is a method for estimating and evaluating the environmental impact of a product or system over its lifespan. So I made environmental impact red, okay, here because sometimes LCA studies are thought to include also other components such as the social component, and others, no. But actually, LCA, strictly speaking, only includes environmental impact. That's why it has expanded now to, say, for example, life cycle social analysis, okay, or life cycle sustainability analysis to be more holistic. Okay? But the important thing is you understand and appreciate the basic framework as well as the basic tools, okay, that is used in LCA. And LCA enables this by providing a framework to systematically investigate the inputs and outputs of each life stage with their corresponding impacts. Okay? Bakit kailangan ng mga tools na na-develop under LCA? If you recall yung example ko kanina on the burger, okay, pwedeng maging very complex yung analysis and very data intensive. So how do you deal with the complexity and the amount of data that you have to deal with? So yun yung usefulness ng tools under LCA. Now, these are the definitions offered by the US EPA, Environmental Protection Agency, and the International Standardization Organization, or ISO. Okay, so they basically are the same, no? You're looking at the entire life cycle and you're focusing on the environmental impact. Okay, so again, these are the life cycle stages as we mentioned earlier. Okay, so ano ba yung binabanggit ko na ISO framework? Okay, so ito yung simple lang siya, guys. Yung life cycle assessment framework offered by the ISO, which was provided in 1997. It has 4 components, as you can see here. You have goal, definition, and scope. inventory analysis, impact assessment, and interpretation. And as you can see, two-way lahat yung arrows natin because there's always feedback going to and back. Okay? Back and forth yung feedback natin. Okay? Kahit dun sa interpretation. So this means that you can iterate, no? Iterate. Kahit nandun ka na sa impact assessment stage. Okay? So depending on your interpretation. Okay, so yung framework, it includes setting the goals and scope of the study. Ito yun. Compiling an inventory of inputs or outputs, so inventory analysis. Evaluating potential impacts of those, so that's impact assessment. And then interpreting results of the inventory and impact assessment in context of the study objectives. So this is the one. So that's why you have to integrate what you see from the inventory analysis, impact analysis, and go back to your goal and scope definition. And of course, suggesting improvements for future benefit. Okay, so that's why if you look at the topics that we have in this class, they pertain to this, and that. Okay. So let's talk about a brief history of LCA. As I mentioned earlier, actually ang predecessor ng LCA, no, the environmental version, is life cycle cost analysis. Okay? And so now, naging subset na siya ng LCA, and that's why one of the topics that we will discuss is LCCA. Okay? And of course, it's cost focused. Okay? And it's a big factor in infrastructure management. We included LCA as a factor in decision making for procurement. Okay? And maybe that's in the context of the cost itself, including the first time cost as well as the recurring cost, but also environmental impact. So the initial works on LCA was actually focused on energy. Energy. So in 1969, the first multi-criteria study for Coca-Cola was performed. No? So it was a choice between, it was a choice between glass bottles or the plastic bottle, okay, for the container. And there was also a choice being made between internal or external container production. The end-of-life options were recycling or one-way. Now, the result of this study was that plastic bottles were actually better, contrary to expectations. However, this study was never published. Okay, so there was the question of validity of the study, and this is a running theme. So because of this, there was a call by the scientific community for a standardization of the process for performing such kinds of studies. And therefore, in early 1990s, the U.S. Environmental Protection Agency, Society for Environmental Toxicology and Chemistry, etc., they tried to come up with a consensus with respect to the standard process by which one should conduct LCA that is acceptable to the scientific community. Okay? Kasi if you have a standardized process, then the results later on could be more easily validated and could be more acceptable to the wider community. Okay? So in 1997 to 2000, International Organization for Standardization came up with the 14040 document. Okay? And the framework for LCA was actually actually became a piece of the global EMS standard. Okay, and the first international LCA standard consisted of these documents. So itong apat na to. The first one, environmental management life cycle assessment principles and framework. The second one shows you the requirements and guidelines, and then you have examples of application, and you have data documentation format. So I will share these documents later on with you. Okay, so it's like you have they had to do this so that the community will have a language. Okay, a language that they can use so that they can understand each other. Okay? So yeah, so yan muna for now, no? Yan muna for now ang pag-usapan natin. Do you have any question? I hope the first part of the lecture has helped you in gearing up, okay, towards the rest of the semester and motivating you in further studying LCA. Okay, and I hope the course guide was clear enough to guide you in fulfilling the requirements and helping you in learning more about LCA through the semester. And that's the end of our session for today.
Again, if you have some questions regarding today's lecture, you may post them under the forum link in Vle. And these questions will be addressed in the next session.